Wecoso Solutions is pleased to present the lightweight expeditionary power system for consideration for battlefield deployment power management. LEPS, as we call it, brings a unique combination of performance and robustness, making it ideal for the most demanding applications. Wecoso Solutions, an AS9-100D company, is located in Huntington Beach, California, and has been providing the Department of Defense and NASA with practical solutions in the power, cryogenics, and aerospace electronics fields since 2015. Our competitive advantage is the major prime experience, perspective, and insight of our big defense technical experts, deployed to meet your needs with small business cost efficiency and flexibility. To use a boxing analogy, we punch well above our weight. We are nimble and adaptable, and at the same time bring prime-level technical excellence. What is LEPS? In short, LEPS is a hybrid solar lithium-ion battery system architected to provide power in locations and situations where grid power is unavailable or unreliable, or when diesel power generators are logistically challenging or impossible. LEPS implements a next-gen high-energy density lithium-ion cell with built-in safety features. This novel battery technology is deployed in a system optimized for ease of use. The single module controller battery with high reliability dual bus electronics is packaged in a drop test proven watertight case. To our knowledge, this combination of robustness and performance simply does not exist elsewhere. This is the back of the baseball card type information. There is too much information here to brief in detail, but let's highlight a few key features. In regard to input power, LEPS is designed to accept up to 2 kilowatts solar, but it can also operate off a DC source such as a Humvee battery, and it can accept a wide range of AC power forms to provide operation off third world and otherwise degraded grids, as well as, of course, AC generators. There is a total of about 3 kilowatt hour of energy storage in a LEPS, and each LEPS can provide 1.2 kilowatt output. Environmentally, LEPS is extremely robust, passing the 30-inch drop test required implementing a shock isolation system inside a hard case, and we have done some testing at up to 60 inches that looks promising. It should also be noted here that the rain and dust requirements are met operationally, and when the system is fully cabled, i.e., not just when the dust covers are on the connectors, which to us invalidates such claims made by others. From a user perspective, together with our Marine Corps sponsor, we intentionally pursued a minimalist approach for ease of use. LEPS has just 3 switches: a master enable switch, a blackout switch, and a source selector switch. The LED displays include a connection indicator for each power input and output, the battery state of charge, and discharge time remaining at current charge level. The simple, clear fault indicator system includes over-under temperature indicator, battery faults, and overall system fault LEDs. There is also a generator auto-start signal for integrated generator operation. Finally, there is a micro USB port for connection to a computer. This primarily being for depot operations where more detailed data insight might be of interest. Before moving on to the enabling technology, we briefly want to point out that LEPS is not limited to just 1 kilowatt loads. In fact, LEPS was designed for modularity with droop share ganging of the outputs as illustrated here. Up to 5 kilowatt loads can be supported with a LEPS system. The first of 2 key technology enablers to highlight is the dual bus architecture, which maximizes performance on the input while ensuring a robust, glitch-free 28-volt output. Solar-based systems are notorious for instability under the inherently transient source and load conditions, but the dual bus allows one battery to be charged while the other supports the load, avoiding the characteristic dropouts seen in competing systems. The other key enabler is our large format lithium-ion cell with high energy density and intrinsic safety. This safety is provided by the patented SafeCore technology developed by our partners at American Lithium Energy, which inhibits catastrophic failure even under extreme abuse, such as crush penetration, overvoltage, and over temperature. LEPS has been developed over a 7-year period with the extended timeline due to gaps between SBIR funding and, even more so, significant requirement changes mid-program. Everything got locked in and fully funded in about the 2019 timeframe, and the second Phase 2 SBIR recently concluded with 3 deliveries and a suite of successful tests at the Navy Surface Warfare Center in Carderock, concluding the LEPS development at TRL-6. LEPS is now seeking a transition partner and specific transition opportunities. In a bit of a recap, the key advantages of the LEPS technology are safe core cells, which deliver intrinsically safe lithium-ion power while resisting catastrophic failure even under extreme conditions. An energy density which is twice that of existing lithium iron phosphate technology, a dual bus architecture which is robust, operationally reliable, and easy to use, a multi-channel solar MPPT which maximizes the solar energy that is scavenged, and a low impedance laser welded battery package that is lightweight with low internal losses to enable a wide operational temperature range. Through these technology, LEPS provides a unique combination of performance and robustness. Wecoso Solutions is open to modifications of LEPS, and one of the suggestions under consideration is adaptation to the 6T battery format. This is certainly doable. Since the start of the LEPS development, the 6T vehicle format batteries have matured and become an emerging standard across DoD. There are no technical barriers to adapt LEPS to the 6T or any other format for that matter. The LEPS battery charge controller can be configured for a variety of voltages. Minor modifications to the hardware and software interfaces would enable LEPS to be usable with any 6T battery. A LEPS using a 6T battery could reduce cost, but it should be noted that energy density would be reduced as compared to the custom LEPS battery. Dual battery systems could be possible with one integrated battery and a connection for an external battery, or a larger system with 2 integrated batteries. In short, a wide range of options are available if of interest. Just ask us. The LEPS battery technology is an excellent platform for any application where robustness, safety, and high energy density are all priorities. The high cycle life and low impedance are also advantages for LEPS, where lifetime and efficiency are additional priorities. We are primarily targeting military applications while we drive down cost to compete in the commercial market. Wecoso Solutions is pursuing 3 complementary paths for the LEPS platform. First, low-rate initial production of the existing design. Performance and safety have already been demonstrated. LEPS still needs a formal UN 38.3 battery certification, which we expect to be straightforward, as well as a design for manufacturing and assembly cost reduction effort prior to full production. Path 2 is adaptation to the 6T battery, as we just discussed. Here we have 2 options. 1, source a qualified 6T battery, or 2, develop a 6T format design based on safe core technology. Either approach is straightforward. The decision will be based on customer needs. Lastly, adaptation of the LEPS architecture for a new con ops with different power levels. Source and loads and a different battery is being investigated. Wecoso Solutions is aggressively working these multiple transition paths for LEPS. In conclusion, Wecoso Solutions has demonstrated a high-performance, next-generation technology for expeditionary power applications. We are actively seeking a transition partner for our LEPS system either as is or with adaptations. We look forward to speaking with you about these possibilities. Thank you very much for taking the time to watch and listen.